Hi students, to prepare two pieces of A4 paper consists of T 7.1, 7.2, 7.3 and also 7.4. We have a total of 2,000 students today at UMK Jeli campus. We found that the total students, they have the average of 176 cm tall, mahasiswa only. And then their standard deviation, mahasiswa, is 6 cm, plus minus 6 cm. We have three questions. We want to find what is the priority for each of the questions. Question number 1. There is a volleyball coach is coming from Kuala Lumpur and he wants to find one individual that has the height of 180 cm or above. Sorry, not above, it's more than 180 cm. Very tall mahasiswa. Is it easy to find this mahasiswa? If at the end, the area that we're going to shade is very huge, is very big, it means that easy to find. So roughly, we want to find somebody is 180 cm or above a mahasiswa. So the area is the red color. Is it big? Later on, we're going to use a number to determine is it big or not. Second question. The volleyball coach, he wants to find a team, not a person, a team. And the team consists of 16 mahasiswa. And his requirement is, okay, as long as these 16 students, their average is more than 180 cm average. Maybe a few is short and a few is tall. As long as average is 180 cm, is it easy to find this team? If at the end we can construct and find the big area, means that it's easy to find. The third scenario, similar to the second scenario, except that there is no information about the standard deviation population. We don't have this number. So still, is it easy to find this team? The average of this team, 16 students, they are 180 cm or above. Let's look at forming so-called the numbers to find the area, is it big or not. We're going to follow the 4 big steps like last week. The first step is, what do we want? And then what do we have? Next one, what formula can we use, how to solve it? And the last one is, what is the conclusion? For the case number 1, just to find one individual, one mahasiswa that's very, very tall, 180 cm or above. Is it easy to find or not? Let's look at our, what do we want? We want to find one individual. The height is more than 180 cm. When we're going to write in form of mathematical notations, we're going to write like this. I want to find the priority. The individual, the height is more than what I want. I want is 180 cm. This is what I want. Step number 2, what do I have? Let's check. We have the continuous data. The height in cm. We assume that our distribution is bell because extreme case, very tall person, not many. Very short person, not many. Average height, yes, a lot. We have a bell shape. Population is from UMK Jeli campus, all mahasiswa, November 2024. We know that our population mean, the average given by the pentadbiran, let's say they give us this number, 176 average from these 2,000 students. And the plus minus standard deviation is 6 cm. In order to find individual, the priority, we can direct use the normal distribution, this formula. To use the formula, we're going to write, I want to find the priority. The individual is 180 cm or above. So will equals to the probability. Why we need to change to Z? Because we need to rely on the Z table to find the probability. To find the Z score here from the Z table, we need to change the 180 cm becoming Z. How to do that? We're going to use this formula. I want to find the Z. X is what I want. I want 180 cm. Mu, this is the average, 176 cm. Sigma is the standard deviation, 6 cm. So plug everything inside, we rewrite it, and we'll have the simplified number is Z is greater than 0.67. Then how can we get so-called the 0.2514? That is to use the Z table. We're going to get from the Z table here. So at the end, the conclusion will be the probability of finding somebody is 180 cm will equals to 0.2514. That will be 25%. It seems that it's hard, just 25% that we can find somebody is 180 cm or what is more than 180 cm. Case 2. The volleyball had abandoned the ideas to looking for one individual. Now he said that I don't want to look for that one individual. I want to form a team. And now I just close my eyes and randomly select 16 students to form that team. What will be the probability that this team, the average is 180 cm, more than 180 cm? Is it too easy to find this team from this 16 mahasiswa? We're going to write in mathematical notation. I want to find the probability to form a team, and the team average height is more than 180 cm. So for this question, what we have is the population mean given by the pentadbiran. Pentadbiran also gives us the population standard deviation, and we have the sample size, that is the team, a total of 16 students, 16 mahasiswa. The formula when we are getting from the sample is to use the sampling distribution formula here. It's quite similar to the normal distribution formula. Now we need to include the sample size into the formula. So we're going to plug the X is what we want. We want the team is more than 180 cm. So we're going to write 180 cm. The mu is the average, the population average, population mean, 176. And then this is the sigma. Sigma is the standard deviation. N is that team, that sample, how many? We have 16. So we're going to include 16 into the calculation. So we have 6 and divide by 16. After the calculation, we get the one number is 2.67. Now we have the Z 2.67. We don't want Z, we want the probability. As such, we need to ask the Z table to convert from the Z number becoming the probability. So we find what is the intersection, and we get the probability is 0.0038. Means that the volleyball coach, when he closed his eye, from 2,000 students, he randomly selects 16 students. Will that 16 students will have the average of 180 cm or more than 180 cm? The probability is very, very, very small, just 0.0038. So difficult, very difficult to form this team. Case number 3. Case number 3 is same as the green color case number 2 just now, except that we don't have the population standard deviation. In this case, we're going to use the student t-distribution formula. When we look at this formula, it's quite similar to the sampling distribution formula, except that now we're going to replace the standard deviation population with the sample standard deviation. For this case, we are given the number is 8 cm, the sample standard deviation. As such, we're going to replace all the values inside this formula, and later on, once we plug inside here, so we're going to get the t. From original, we have the variable is in cm. Now we have in form of t-score, but we don't want the t-score. What we want is the probability. So we need to ask the t-table come and help us. The difficult part about this kind of student t-distribution is to convert from t becoming probability. It's a little bit complex. Later on, you try to see how is the calculation done from the given table here. We need to find the ratio in between the t versus the p. So later on, you check at the example there, and at the end, we're going to get when t is 2, it is equivalent to probability 0.0337. So it's a very small number, means that the volleyball coach, is very difficult to find the team that is more than 180 cm or above. This is the full version. So you can later on go through this page only. Now you want to start solving tutorial question. The first question is 7.1 related to the normal distribution, the gray color problem, to find one individual. This question same as the just now box questions. Given there is 2000 UMK Jeli mahasiswa and their population average height is 176 cm and their population standard deviation is 6 cm. Now find the probability and number of randomly selected mahasiswa, one mahasiswa, is more than 180 cm. What would be the probability? And how many students that is 180 cm or above, more than 180 cm? Okay, we look at how to solve it. Because this problem, we have the continuous data, and then we have the population average and population mean, we have the population standard deviation, and then we want to find individual height more than 180 cm. Means that we can use the normal distribution formula here. So later on, you can see plug into the Z formula there, Z score formula, and then later on, we're going to get the Z is larger than 0.67. We need to convert the Z becoming the P. We're going to use the Z score table. When Z equals to 0.67, Z equals to 0.67, here, P is 7486. Unfortunately, this table is looking from left to right. Are we looking from left to right? No, because we want the student is very tall. Means that we are looking from right to right here. Or to say that our P that we want is 1 minus 0.74 is 6. So at the end, our P equals to 0.2514. So when we have the P equals to 2514, we need to tell the volleyball coach, is it easy to find this individual or not? That's very tall. That is more than 180 cm. Then later on, we can times 2000, all of the students, to get how many students that is very tall in the campus. Question 7.2. Given 2000 mahasiswa, this is the green color questions. The population height is 176 cm. The population standard deviation is 6 cm. Now, if the volleyball coach want to form the team and he randomly close his eyes, select 16 students, will he going to get these 16 students, their average will be 180, will be more than 180 cm. So follow the same procedure from the green color box earlier. We're going to use the sampling distribution formula here. So plug everything inside the formula. So we're going to get Z is greater than 2.67. So Z is not what we want. We want the probability. So we're going to ask the Z table to help us. Z 2.67, where are you? 0.9962. Unfortunately, again, this number 9962 is referring from left to right. What we want is right to right because we want the tall area there. So we need to 1 minus 0.9962. So we get a very small number there. So at the end, we're going to tell the coach that, coach, you can forget about the intention to find this 180 cm average tall team. It's difficult, just 0.0038. Next, T7.3 is similar to the yellow color questions. When we compare to the green color questions, the only thing that we don't have is the population standard deviation. For this problem, we don't have this one. Means that we need to find what is the sample standard deviation. Assume that we did the calculation and the sample standard deviation is ACM. Now we can use the student T distribution. We're going to plug inside what is the average height that we want is 180 cm. This is what we want. The mu is the population mean. This is from the Pentaveran. We have 176. S is the sample standard deviation. That is 8 cm. And divide by the third n. And we have 16 students, 16 mahasiswa. Now we're going to simplify and we're going to get our T is 2 from here. This is 2. We don't want the T. We want the P, the probability. Means that we are asking the T table help us to convert from T becoming the P. For the T table case is more complicated. Why? Because we need to consider two things. The first one is what is our degree of freedom, DF. This is taking our sample size. We have 16 mahasiswa minus 1, 15. Means that we're going to refer this row. Next one is, what is our T? Our T is number 2, exactly 2.000. 2.000 is in between here. It's between 1.7 up to 2.1. Somewhere here. Means that later on, our P will be between this number 0.05 until 0.025. What is the exact number of our P? This is a difficult part. Kindly check at the steps inside the box below here. So we are taking the ratio between the T2 and P. So later on, we can find what is our P. For this case, we get our P equals to 0.0337. This is a very small number. Means that it's difficult to form the team with the average height is more than 180 cm. T7.4. This is you going to create a new question which quite similar to 7.2. 7.2 is the green color problem. We're going to use the sampling distribution formula to solve. For example, you can write your problem like given UMK farm has 500 pineapples and the average weight is 1.2 kg. Standard deviation is 0.4 kg. Now, find the probability I randomly select and can form a basket. And inside that basket, which consists of 20 pineapples, the basket has the average weight less than 0.9 kilograms. What would be the probability? I close my eyes, I randomly pick how many? 20 pineapples from this farm I put inside the basket. What is the chances? What is the probability that the average weight of this basket is low, just 0.9 kg or less? Using the same step under the 7.2, you can solve it. After you solve this problem, you're going to take a video and then upload to the YouTube, and then on submit your YouTube link at the given Google form here. This is the eCampus instruction. So just follow the eCampus instruction. And the final one is you're going to watch and like your friends' YouTube. Okay, bye bye.